Okay, so we are in the first session today, and this is my profile, contact information. You already have my email ID probably. So my name is Shekhar Aripaka, and I'm by profession a solution architect working for one of the MNC, and also a part-time .NET trainer. And you can add me in my Facebook or LinkedIn, Twitter. I'm not that active, but definitely I would encourage all of you to add me into your profile. And that's my Gmail account, and also Yahoo. So most commonly I will use the Yahoo as the prime email account. So keep in mind, this is not yahoo.com, this is yahoo.co.in, and there is no A in the Gmail and Yahoo account. Otherwise, in Twitter, LinkedIn, Facebook, you have a full name as Shekhar Aripaka. You can search by that name and you can add it. Okay, good. So that's about me. So in the industry, I have about 14 years of experience so far, and as an architect, I have roughly 6 years experience, and I'm here teaching you .NET for you. So about the training material for this sessions, I don't have any specific training material that I can actually offer you as a Word document or a PPT or something like that. Because the reason being, there are a ton of materials available online, and there is no reason why I can bring up my own set of materials. My preference or my preferred link for the material is the MSDN. That's my first preference. If you take a look at the link, I will distribute this link via email to you. If you look at this link, it's if you're completely new to .NET, these links will definitely help you in getting your feet wet. And of course, the online training session, whatever we're going to have, the topics that we're going to cover, and the examples that we're going to see, they are self-explanatory. And if you want to learn more about those topics, then you can always go to MSDN and also refer to these these online resources like the C# Corner. I want to spend a couple of minutes in this material, especially the second link. This link is a very useful link. Those who don't know what is MSDN, MSDN is a Microsoft published developers network. This contains all the developer references online. So in other words, all the documentation that is required for you to use any Microsoft products. Since we are going to do a C#, and the landing page here with the link gives you the information that you, as a beginner, you can make use of it. Like in the first instance itself, you have a link called Getting Started with Visual C#, and it has step-by-step information of how to use your Visual Studio IDE, how to bring adding resource to C# programmers, and so on. It's a very detailed documentation available here, and that's the reason I am not bringing up any new documentation from my end, because I don't want to confuse or have an outdated information. So the online portal in MSDN will always have the current information available. So this is the best place where you can refer to for offline study. Okay, and another thing is the C# Corner. So once you know the specific topics that you want to explore more, of course, if you key in the Google, it will definitely going to give you a good set of result sets. And also the C# Corner, if you can create an account if you're not there yet, it has a lot of articles written by many people who it's topic by topic. You can have, sometimes you'll have a step-by-step information as well, how to use a specific control, how to write an code in, for example, lambda expressions or anonymous methods and so on. So you can have a detailed article or step-by-step, sometimes even with the source code, so on. So it's the best reference point for you to walk through the reference. So ton of material is available outside. The only thing you need to know is where to look and how to look. And if you don't remember any of these, you can always go with the Google or Blink and search for the keyword. You will see ton of material outside. Okay, so that's the reason there is no handouts or a separate material that I'm preparing. I will circulate the topics that we are going to cover definitely, so that will at least help you to look up down the line. And we'll start with what is a .NET framework today. So what is it? So the .NET framework got released in Feb 2002. That's the first version, which is 1.0. Okay, saying that, so .NET framework is a type-safe and object-oriented programming environment for developing platform independent and secure applications. So all the highlighted in blue keywords are critical to understand when we define what the .NET framework is all about. And type safe, when we talk about, we are going to see more example based answers to this. To just give a quick overview, what is the type safety means? Type safety means assigning or having a variables or memory areas specific to a given data type. For example, a data type like an int or a string or a date time and so on. So all these are specific data types, and when you declare a variable or memory location to store a given value of a given type, that memory location should always refer to the same data type throughout its life in the program. So that means the type safety. And when it cannot happen, so example, if you look at the variants or var in Java. In JavaScript, if you have a var keyword, the only data type available in the JavaScript is a var, which is like a universal data type, which can take any data value throughout this program life cycle. So there are a lot of disadvantages with that, because if you don't have any control and what is the value that you can assign to a given variable, then there are a lot of logical errors that can result out of the program. So type safety is one of the very key strong feature in .NET. Okay, and the object-oriented programming environment. So the .NET is completely an object-oriented programming. So what is an object-oriented programming? We will see in detail in one of the session. Don't try to miss that session. I'm going to give you a very detailed code examples, and it's going to be at least a 2.5 hour session down the line. We will be talking about object-based programming and also object-oriented programming and aspect-oriented programming as well in that session. So don't try to miss that. That's going to be a very informative session. So .NET is completely object-oriented programming, and if it is completely or not, it's a debatable thing, but we will see more in that, more of that in next session. And it's an environment for developing platform independent and secure applications. So what does that mean by platform independent? Means the platform in this case refers to the operating system where the program runs. So it's critical to know the name, how the framework is given. It's .NET. So what it ideally refers to is the internet world, and dot is a period operator, in other words, and the name itself self-explains the need to be a platform independent. The need of a platform independency comes into picture especially when the applications are heterogeneous and they run on different operating systems. They need to run on different operating systems because the internet itself is a network of networks, and the given machine participating in a given network can be of a different operating system, and so the applications or the communications happening between two different computers with the two different platforms, that is two different operating systems, need to happen, and that's very critical to have an application running on the internet. So for that to make it happen, .NET Framework is become a platform independent programming model. And how it is possible, we will see how this platform independency is achieved in the today's session. And also it provides a secure application, so it's going to be used for secure applications. Again, going back to the internet world, having applications running on a heterogeneous systems, it's critical that the security of the applications running on a different machines is ensured. Saying that, so if you see a malware that's running in your machine or coming down to your machine and deleting all your hardware resources or memory, accessing your memory, it can happen. So we see this viruses is a very common threat in the internet world. So any damn program come and sit in your machine and eat up your hardware resources, crash your operating system. You can eat up your even boot sector and a lot of things. So writing programs in .NET platform has a unique features called the code access security features, which will not allow any programs. That means which is written in the .NET, not any other. If you write in a C program and let it do anything, then .NET is not going to save you from it. But so any program that is written in .NET language are secure while they are executing in a given operating system or a given environment. So how this is achieved, what is the code access security is all about, and how it is done, we will see in detail. So all of these keywords we will see in detail. So just going to give you some glimpse or overview of what they mean all about. Okay, so that's the overview of the .NET framework in a 3-line statement. Okay, so .NET framework can be used to develop the following types of applications. So we have almost 6 types of applications which can be created using the .NET framework. The number one is the console applications, which we are going to see in almost all these sessions. So since the main focus in this training program is to learn the language, I'm not interested in showing you all these different flavors in to learn the language. So what we need is a console application, and it's pretty much going to be straightforward. We will not see any GUIs at all. We will run everything in the console application. And then and number 2 type is the GUI based applications, which are Windows GUI based applications. And the third one is the web applications. The fourth one is XML web services. Fifth is the Windows services, and the 6th is the mobile applications. So we are not going to see the mobile applications and also Windows services, but we will see as part of the project at the end of the session, we will see all the number 4 up to 4. Console application, Windows GUI based applications, we'll see ASP.NET web applications, and also XML web services using WCF services. Okay, so we'll see all of that. Good. And this is the version stack. This is again, as I said, as a keynote in the beginning of the training program, that it's important for you to know which version got released when, and which of the Visual Studio IDEs come with by default version. So if you see, the version 1.0 got released in Feb 2002, and 1.1 got released 1 year after that in 2003, and it's available by default in Visual Studio 2003, Visual Studio .NET 2003. And after this, the naming has changed. They removed the .NET keyword from the Visual Studio itself. So after that, it started calling as Visual Studio 2005. Wherein the 2.0 version got released, and this is the version. If you see 2.0.50727.42, this is the version that is more stable than any of the other versions. So 2.0 has been a very successful release, and till 4.0 the core version was not actually changed. So we still refer to 2.0 libraries in even the 3.0, 3.5 framework version. So the base library is almost frozen till the 4.0. 4.0 they have added a couple of new additions. Only they need to modify the base libraries because of the parallel parallel processing or parallel task library that added up in 4.0. Okay, so this is important, and this information you can actually get it from Wikipedia. If you search for .NET Framework in Wikipedia, you will see this table. So this is a table I extracted from Wikipedia. Okay, so there's no need for you to write this down or memorize this, but Wikipedia will have this information. And of course Visual Studio, and again a default in Windows operating system. If you see, this is another key thing that is important to remember. So the last version 3.5 is available in Windows 7. So Windows 7, if you see the operating system, that's the latest operating system which is released one. And also at the server side, we have a Windows Server 2008 R2 is the latest in the market, and they come with 3.5, not 4.0. okay, so because it got released after these operating system got released. Of course Windows 8 is going to come with the default operating system, default framework 4.0, and of course Visual Studio 2010 is the current latest version. And of course if you know, many of you might know, Visual Studio 2011 developer preview version is already available, which is again focusing in integrating the Windows 8. So Metro Life applications are the applications that you can build using 2011. That's a very interesting feature. If at all you want to take a look at it, it's going to be really very good features. I like them. I'm just waiting to explore more on 2011. Okay, so that's about the background of the version stack of .NET Framework. And one important thing, with my experience, I have seen people do normally get overlapped or confused between the various versions. Like for example, Visual Studio has its own version cycle. Okay, so and .NET Framework has its own versioning. So Framework is a different from IDE. Visual Studio is just an IDE wherein you can manage the projects, build the projects, debug them or troubleshoot them, things like that. So it's an IDE, whereas a framework is a set of libraries that can be available, and the version for framework is different from the version from the Visual Studio. Similarly, there are a ton of other things like if you talk about ASP MVC, it has its own version cycle, so it's all independent to each other. So that's the key thing you need to remember. So not all are not same. So when I say 4.0, it's specific to the .NET Framework version. And we'll see most of the Framework 4.0 versions features, but not completely. And this is a version stack of .NET Framework. In that context, so if you take a look at the features available or released as part of the various versions, as I said, 2.0 is one of the most robust base version on which we have the Windows Forms, ASP.NET and ADO.NET for data access, and the base class library here sitting at the bottom, and the bottom, the blue one, is the CLR, a common language runtime. And we will see most of the CLR and also BCL, and of course ADO.NET we will see at the end of the session. ASP.NET we will see at the end of the sessions, and WinForms we will see at the end of the sessions. We are actually going to see mostly the base class library in the entire training process, because that's the foundation. As I've been saying, that's the foundation. If you know the BCL and CLR, how they work, and how can you use the BCL to create make use of the various language features, then you can do all of the items on the stack. And 3.0 came with the more powerful features called the WPF, Windows Presentation Foundation, and the WCF, Windows Communication Foundation, and the WF, which is Workflow, and card space. This is again card space again is a very useful one, especially when you do with the single sign-on features. So it's related to the security model where you can create your authentic tickets and pass it on for authentication across the applications. And 3.5 came with again a much more powerful feature called Link, LINQ stands for Language Integrated Queries, and there are three forms to it. Number one is link to objects, number two is link to SQL, and also the third one is link to XML. So again, this is a very, very powerful feature. We will see link also when we see the 3.5 features. We are going to see 3.5 features wherein we will focus more on the link, but not as a query, but we're going to see how it works internally. One of the good advantage in my sessions is I will be taking a deep dive into how things work internally, wherever possible or wherever feasible, and I'll try to take a deep dive. And 4.0, the latest one, have much more powerful features called the parallel link and the task parallel library. So this is again very interesting to know. If you look at the latest multi-core processors available in the market, even in the home-based PCs are available with dual-core or quad-core or more multi-core processors. So if you look at the server side, you can have cores, unlimited cores in the data centers. So to gain the advantage of these multi-core processors, so the .NET 4.0 has added up all these parallel link and task parallel libraries. So these are pretty similar to the multi-processing and multi-threading applications, but the limitation with the multi-process and multi-threaded applications is that they run on the same core, which goes to your hardware processor. If you want to take the advantage of the dual core multi-core processors, that's when you need to actually specifically write a code to gain that kind of extendability or scalability solutions. For that, you have the parallel link and task parallel library, and again, it's not complicated completely. If you know the link, and there are a couple of new keywords that you need to add up to the link to make use of the parallel link. And I'll give you a rough picture. In normal link in a single core processor, if 1 million records, if it takes 2 minutes to process, the same process you can actually scale up with the quad core processor, and the same 1 million records can be processed in almost 30 seconds. So that's kind of a performance improvement you can gain using the parallel link or task parallel library. So that's a very, very strong feature available in 4.0. Okay, good. So that's about the version stack, and we'll come down one level down. So this is a very common stack component stacks of .NET framework, which you can see, which you might have already seen online. This is published by the MSDN again. So this shows the way the components interact with each other and what is used for what. On the on the right hand side, if you see the blue box here, the Visual Studio.NET, as I've been saying, this is just an IDE, which is interactive development environment, which can be used to manage all these various components of a .NET framework. And if you see the complex services, you can actually interact with the complex services within Visual Studios. Okay, again, I don't want to overemphasize on Visual Studio at this point. Our emphasis should be on the left-hand side components, especially the .NET framework base class libraries. So these are the libraries which are pretty much a compiled assemblies available as a distributable components, and those can be consumed within your application. And you have the CL at the bottom, which sits on top of the Windows or the complex services. Okay, so the CLR is, again, as you see, it's an intermediate communicator between the Windows or operating system. In other words, it's an operating system, you can say. In this case, it shows just Windows, but this can be even Linux or Unix or anything, any other operating system available in the market. And it has its own operating system specific CLR that can understand the operating system. And on top of that, we have the base class libraries, which are all these subsets, all the DLLs that are available, or distributable components that you can actually install on the given operating system as an installer, like an MSI installer. And of course, they are specific to the given platform. The ASP.NET sits on top of the base class library, and again Windows Forms sits on top of the base class library. So this tag again gives you the dependencies on one on the other. So although they are decoupled from each other, but they are dependent on each other. So that what it means is CLR cannot run on its own because it still needs an Windows operating system to run. Okay, so that's the base thing. So of course the operating system is the base thing, it should be there, and CLR can only sit on top of it. And at the same time, base class libraries cannot interact with Windows operating system directly. So they need an intermediator, which is called a CLR. So that's the relationship this diagram is showing. Okay, so not only this diagram, if you down the line, if you get into any job or any project, if you see any such architectural diagrams or components diagram or stack diagrams, one thing you need to understand is the stack, the way they are stacked on one on the other, one on top of the other, indicates that there is the dependencies on each other. Okay, and ASP.NET is dependent again on the base class libraries, and of course, as I said, we will be talking more about the base class libraries, and in the applications we will make use of them. And common language specifications, again, this comes one of the interoperability feature that's available. We will see what is CLS again. And on top of that, we have the languages and the various languages. So this is where the language interoperability is possible, because the language sits on the topmost in the ladder, and of course all the others sit on down to the others. So these are the component stack of .NET framework. And this is a common language infrastructure. So what this indicates is the various languages, as we see on the top of the ladder. C# as a language, or VB.NET as a language, J# as a language, or F#, which is a function-based language again, and of course you have more Python or Ruby and so on. So there are a ton of other .NET specific languages, and each of the language have their own compiler. So once you compile the respective code with the given compiler, it's going to emit out a CLI. It's called Common Intermediate Language, which I believe most of you are familiar with. What is a Common Intermediate Language, CIL? In other words, it's sometimes referred to as a MSIL, Microsoft Intermediate Language, and also simply IL, Intermediate Language. Okay, so this could be, this is one of the most common questions people do ask in the interviews. What is an intermediate language? Remember the keyword language. So it's a language by itself. Normally, traditionally, other compilers, like if you see C program, if you compile the C program with respect to compiler, it's going to emit out an exe that can execute itself on a given operating system. So the exe will have the binary instructions to the operating systems directly, which an operating system can understand. So in .NET, it's completely different. So when you compile your code, it's not going to give you a machine understandable binary instruction code. It's going to give you something called MSIL. So MSIL itself is another language, just like a C#, just like a VB.NET or J#. MSIL itself is another language. If you learn MSIL, then you can actually write code in MSIL, as simple as that. So again, saying that, what I'm referring to is you can actually bring up your own language Like for example, if I'm referring to myself, I can bring into my own language saying Shaker Sharp, and put my own instructions, put my own data types, put my own language syntax, literals and everything, and build my own compiler, because my compiler understands my code, and my compiler is going to emit out an MSIL. Then I can plug in my language into the industry, so into the .NET framework. So that's how it is possible. So that's how we have G#, we have F#, and so on. So many other languages that you can plug into the model. So MSIL is a core thing which is understood by the CLR. So that's why this is called a common language infrastructure. So this piece is called the common infrastructure or language infrastructure, wherein you have the MSIL and the common language runtime. So once this MSIL is available, the CLR is going to compile it to the binary instructions to the operating system, which is going to be your zeros and ones in the binary language, if you remember. So that's what the instructions going to be executed on your given operating system. So again, given operating system is again a bold and underline. The CLR can be a platform specific. So what it means is I can write my C# code once and use the respective of course CSC, which is the C# compiler, to emit out the MSIL. And this MSIL I can actually deploy on the given operating system, like say Unix or Windows or Linux and so on. And the CLR is a platform specific version. So the CLR can understand MSIL, and the platform specific CLR can also understand the respective platform. For example, Windows based CLR can understand Windows instructions, so that it's going to read out the intermediate language instructions and translate it to the respective platform specific instructions. So CLR is a platform specific version, and it's between the mutual agreement with Microsoft and other vendors available in the market who produce the hardware peripherals and also the software like the Unix, Linux and other things. So the CLR comes as part of their factory output. So once you buy a given Linux operating system, it comes with the built-in Linux CLR. Again, CLR has its own versioning, and normally we don't really care about the CLR version in ideal scenarios, and that's when the operating system support will also need to be looked at, the other way I showed you in the first slide. So the default in Windows we have here is the support for 3.5 framework, and again if you see the 4.0 framework is not available by default in any operating systems today. So if at all you're getting a Windows 7 operating system, of course if you download 2010 Visual Studio 2010, then you will have the 4.0 framework as part of it. But if you're using Visual Studio 2008 in Windows 7 and you want to use framework 4.0, then it's not available, because Visual Studio comes, or Windows 7 comes by default with 3.5. So in that case, you can of course go and download the framework 4.0, install it in your machine, and also the given server, and make use of it in Visual Studio 2008. But of course there are some issues with that. There's again a hotfix. The reason is Visual Studio 2008, in order to make it a forward compatible, you need to actually install a couple of other additional utilities or a couple of other installers to make it forward compatible to the 4.0 version. But again, it's doable. Okay, so that's all about the common language infrastructure. So it comes with the CIL or IL itself and CLR. Okay, and the core components. Once we get into this, the core, when we see what are the main two things that you can talk about .NET framework, there are two things. One is the CLR and the base class library. Okay, and base class library, as as we see in the other slides, it's a combination of a package of different DLLs. The most important one is the mscorlib, and of course system.dll are a couple of additional DLLs that comes along as part of the base class library. By default, if you create any solution or project in Visual Studio, you don't have to actually refer to the mscorlib. Always remember, this is the core Microsoft core library. That's what it stands for, and it's available. Of course, it's available in this path. If you in my machine, I'm going to see Windows. Okay, FYI, I'm using Windows 7. If at all you're not having Windows 7, then don't try to look up the same way that I'm trying to look up. It's going to be a little different, but it's going to still be available anyway. So I have the framework again. I have framework 64 as well, and framework this, of course, this is the 86 infrastructure. And within this I have the version specific, and as I've been saying, so mscorlib is part of the 2.0 version. So within this folder you will see all these core libraries DLLs. The base class library, whatever we have been talking about, so these are the set of the DLLs like system.dll, mscore. Where is mscore? Yeah, you have so many mscores, but mscorlib is what the most important one. So keep this in mind. So this is the core library mscorlib that contains all the data types that we are normally using, and many other things. We will see what it has inside. We can definitely see what it has inside a given DLL. We'll go there very soon. Okay, so that's the base class library, so which is available as part of the your installer. And yeah, CLR, we're going to see of course again, so these are the different types of libraries available to do different types of programs, like it contains the data structures, IO management, Windows forms, web forms and controls, data access, multi-threading, remoting, reflections. We'll see what is reflection at the end of this session today anyway. Okay, so we'll see what is a CLR. Common language runtime is the foundation of the .NET framework. Runtime is an agent that manages code execution. So if you know what is an operating system, I think most of you are computer graduates, and I need not expand more on the operating system side. So it's literally what all an operating system can do. It's managing your threads, processes, memory, allocation, deallocation, and so on. So of course your hardware peripherals, input devices and output devices, and so on. So CLR is actually interacting with the operating system. In other words, it's an intermediate runtime to execute a .NET program. As simple as that. It's a runtime to run a .NET program. That's a CLR. And in order to do that, what it needs to do is it needs to translate the intermediate language, and also do the policy checks on the security side, like the security, code access security we were talking about. We'll see more internals of a CLR down the line, but for today's as an introductory session, we're going to keep it limit CLR as a runtime to run a given .NET program. And it's a code management. Code management is a fundamental principle of the runtime. As you see, so each and every line of code that's coming with MSIL, it's going to translate into the machine bitcode information, and then pass it on or marshal the instructions to the operating system to fire it up in the operating system side. So that's what the intermediate role that CLR is going to perform. And in addition to that, it does a lot of other things. It pretty much manages the execution of your .NET program. And with respect to the management of the executing program, it starts with reading out the DLL information and allocating the memory, or creating the required number of threads or processes into the memory in the process area, and also manage the the memory allocation, deallocation cycle throughout using the garbage collector internally, and then of course when the program get terminated, it's also comes into play of removing the process threads out of the system and bringing the application to a termination stage. So all that starting to the end stage, the CLR is going to make it possible. And it's the runtime, just like any other programs you normally refer to. For example, if you see VB6 applications or C application or C++ applications, they all have their own runtime. So that means the runtime library set is definitely required for those programs to run on a given program. And here comes another two important aspects when we talk about the CLR. So one is the managed code, and the other one is an unmanaged code. So this is a very common question people do ask: what is the difference between a managed code and unmanaged code? Okay, in simple, managed code is the code that targets the CLR. In other words, whatever CLR can understand and run in its own domain, it's called a managed code, in simple. It could be a C# program, it could be .NET program, it could be a F#, it could be Python, it could be any other .NET based program. Ultimately, it should be an intermediate language. Okay, so MSIL is a managed code, in other words. So anything is MSIL is a managed code. So that means your C# is a managed code, your .NET is VB.NET is a managed code, F# is a managed code. And what is unmanaged code? Code that does not target the CLR is an unmanaged code. That means whatever CLR cannot manage or do not manage or do not understand is an unmanaged code. That means a non-MSIL is an unmanaged code. For example, a C program, if you're running a C program, it doesn't run under CLR domain. It runs in its own runtime. If you're running a VB6 programs, it doesn't run in under CLR domain. It runs in its own runtime. If you're running a C++ program, it's the same thing, and so on. So if you're running a .NET program, it runs within the CLR domain. So that means a .NET program is a managed code. And whereas the others like C or C++ or VB6 programs, they are unmanaged code, or even COBOL or Python or whatever things you can name, which are not MSIL. Okay, so I hope that's very clear. You should never get confused with what is a managed code and unmanaged code. Managed keyword itself refers to the CLR. Okay, so if you remember that, that's the key thing. And full form of CLR is a common language runtime. There's more information about the CLR in this slide, and it forms the heart of the .NET framework. All languages have runtime, as we have been discussing. For example, VC++ has an runtime called MSCRT40.dll. VB6 has the similar DLL, and so on. So respectively, CLR is a runtime for .NET programs. And it internally has a lot of very core components called the garbage collection, and we will be having one complete session just to talk about garbage collection. Okay, so this is one of the area wherein I will take you into a deep dive, because that's very important topic, and also sometimes that's the most least understood topic and least ignored topic. In other words, the most ignored topic. So it's a very important topic, and we will be taking one complete session, that means almost 2 hours session into garbage collection. And of course, CLR uses the garbage GC to automatically allocate and deallocate the memory. In other words, the efficient memory management. And code access security is another thing. So CAS grants rights to programs depending on the security configuration of the machine. So once you write a .NET program, you can actually specify what are the kind of operations that this program can run. You can specify a security policy. For example, we'll take a very good example, as if your program is actually going to handle a file IO operations like creating a file, deleting a file, or truncating or manipulating file system in your machine, then such programs do need a authorization or a policy configured for the given application, for the given program to run in your machine. That's as part of the code access security. So when the CLR loads a given DLL, and it tries, first thing it's going to do is going to match the policy required for the given program versus the policies set up in the language in the .NET setup on the given machine. If both doesn't match, then it's not going to let the program run on the machine. So that means you need to actually make that given program trusted in your machine to do the file IO operations. So then only your program can actually run safely in that given environment. So that kind of a check is done by the CAS, Code Access Security. And as part of the security measure, again, down the line we'll see more of that. So for now we're going to keep it simple. And the code verification. And code verification is a very, very important thing that happens as part of the CLR executing a given .NET program. What it actually makes sure is intelligently, it's going to walk through each and every line of code wherein the program is creating a memory and using a memory location. If at all it sees any line of path or any code path which is trying to read a memory location which is not created by the program, then it's not going to let you run the program. So what it ideally indicates is, if you're trying to access the memory locations other than within your own program domain area, so what it indicates that you're trying to access the memory area of the other programs in the given operating system. So that is likely to be a risk factor for the application. So that's not a safe program to run on your machine. So it's not going to run the program. But again, so a good example for that to do is the pointers concept. If you know, the language-wise C++ and C supports pointers, whereas the .NET programs do not support pointers. But that's again just a quote, okay, within double quotes I can put it as. But using C# you can have you can write unsafe programs and also use this pointer concept to access the memory location, because in certain cases you do have to write such programs. In such cases, you need to explicitly convey to the compiler that I am an unsafe code. So what it's going to do is it's going to skip the code verification process for such programs and take it forward. Okay, so that's a different, that's all about the code verification process that happens. And this is implicitly is part of the code access security itself, okay? Okay, so that's about the security part and base class library. So the .NET Framework class library is an object-oriented collection of reusable classes that can use to develop applications ranging from traditional command line, like the command-based console applications, or GUI-based applications. So as we have been seeing, the base class library is a set of DLLs that sit in your as part of your .NET Framework version. And you can just have to refer to that and make use of it. If you, for example, just have to write a program to do a data access, all we need is the base class library called system dot, where is that? System, yeah. So if you see, there are a ton of each of the DLLs available here are specific to a given purpose. Like for example, system.xml.dll. This is a DLL that you will normally need to use to play with an XML documents, and system.security available, system.web is available, system.web.mobile, so on. So these are a set of DLLs are available, which are a predefined set of functionalities readily available to consume within your application or given type of application. So so that's the base class library. Okay, so that normally eases your development cycle. instead of you writing the base common functionalities, those functionalities are available as a framework DLLs, and that's the richest part of the .NET framework. So there are a ton of things which you can do in .NET with the less code from your end. So everything can be done by using the base class library with small code or less code from your end, and most of the stuff is in the base class library. Okay, that's about the base class library. We don't really need to know more at this stage. Once we get into the respective program features, we will see more of that. Okay, and this not only makes the .NET Framework types easy to use, but also reduces the time associated. That's what we've been talking about. Okay, good. MSIL, again, a couple of more about MSIL. The .NET programs are not compiled directly to native code. They are compiled to MSIL, and MSIL is executed by the CLR. MSIL is the lowest level human readable programming language in .NET Framework. Again, remember, this is human readable. Okay, this gives you this gives me a good a point to show you how an MSIL looks like. We will see that definitely how the MSIL looks like, because we said that it is a human readable programming language. That's what I said, that if you know MSIL, if you can write a code in MSIL, then you don't need a C#. Okay, what's an assembly? An assembly is a unit of deployment. In other words, this is again a very fundamental keyword that one need to know when we talk about the .NET framework. So assembly is a unit of deployment, like an EXE or DLL. In simple, any program, any project that you're going to add up to your solution, the result is when you once you compile it, it's going to emit either two things based on the type of the application that you're using. One, it could be an exe file, which is a self-executable, and another one is a DLL file based on if it is a class library, it's a DLL file. We have seen a DLL, which is not a self-executable code. All DLLs, in other words, DLL stands for dynamic linked libraries, need to be consumed by a hosting application, which can be a exe file. Okay, so that's the intermediate relationship between exe and a DLL. Okay, so assembly, when you talk about an assembly, a DLL or exe, both are assemblies. So there is no distinction when we say an assembly. In other words, so what all we have seen here, all the DLLs, all these DLLs are assemblies. Okay, so that's what an assembly is in a straightforward way. So you can put your line of words the way you want to describe it, the best you can. It's up to you. Okay, so an assembly consists of one or more files. It could be DLLs or HTML files. So within the given DLL or exe files, you can actually add any number of resource files to it. That is fine. So at the end, it's going to be one file as an output. An assembly may also contain references to other assemblies, definitely. Yes, one assembly can refer to other assembly. We will see most of that when we do the programs, wherein one solution can actually refer to another project within the same solution, or another external DLL, so that we can normally make use of it directly, so on. So an assembly can refer to another assembly. And the assembly manifest is one of the key things. So manifest contains the metadata information. So it's a nutshell or container that contains the metadata. And metadata is the information about the assembly itself. It's like a profile of the assembly itself. Like metadata information contains the references to the other assemblies, its version, its product information, its owner information, and what are the security policies it requires, and its strong naming, and a lot of bunch of information. And definitely I'm really want to show you in practice so that you understand these keywords much better. So to show you that, I'm actually going to create our startup project. Again, one step back to it. I know most of you might not have a licensed version of a Visual Studio. For those who don't have a licensed version, so I recommend to get the Visual Studio Express edition, which is completely free. I can actually provide you the links to that, but again, you can also since you're all the computer science graduates, so just go to the Google and search for Visual Studio Express. If you see 2010 Express, you will get the developer tools Express edition here. I'll just open it in the new browser window so that so this is a developer edition, so which are completely free. Of course, they comes with limited features, but no matter. So all that we're going to do in our training process, all that will be supported by the 2010 Express edition, and it comes with a separate installer for each type of application. For example, if you see Visual Studio 2010 Express for Windows phones, we don't want that. We're not going to do any of that. And if it's a Visual Web Developer, again, we're using that. You can actually only do the web-based programs, nothing else. And the Visual Basic here, this can you can use only to create the VB.NET programs, not the C#. And again, the bottom one, you have a C# again, which you can use to create C# programs. But again, we don't want to restrict ourselves, because during my training process, wherever possible or wherever feasible, in most of the cases, I will always compare the VB.NET code versus C#.NET code, so that you will have an idea how the VB.NET code looks like, and by chance, if you have to work with the VB.NET, then it will help you out. Okay, so we'll have so in that case, if you take only C#.NET code here, see C# 2010 Express edition here, then the programs that I write with VB.NET, you cannot open them. So again, this is not the edition that you will be looking for. Again, C++ is not what we're going to do. So what you're going to need is the last one. The Express edition with all, like this is a 2010 Express ISO images, and with this you can actually do Visual Basic 2010, C++, C#, web, phone, everything. So you can do everything with this one. So I recommend you to get this one downloaded and installed in your machine. And with that, the source samples that we're going to do in this training process, I'm going to upload that to the Windows Live link in the cloud. I will actually add all of you to gain access to that cloud interface, where you can collaborate, you can download the source code from there and explore more on the source code, or you can add your own for playing around it, for you to refer it. So you can make use of this for yourself. And of course, similarly, you can also get the database as well if you want to look at it. Like if you see C++ 28 R2 Express, there is an Express edition for a database as well. You can get that as well. Okay. And yes, I assume that you have the Express edition, and once you have it installed, what you will see, so just to show what's an assembly and what's a manifest and other things, I'm actually going to start with the welcome hello world program today. To start with, once you install it, I'll have this available as a program, all programs option, and I have the Visual Studio 2010 here link. So once I hit this, you'll of course see the splash screen and the Visual Studio ID got open. And to create a new project, all I need to do is right click here and say new project. Okay, so today we're going to start with the console applications, and yes, if you see, you have multiple options to choose on the template side. I'm not interested in any other languages, and since I have 2010 Ultimate Edition, so I see most of the templates here For you, you may not see all these templates, but which is fine. Under C#, I'm going to pick the Windows and as a console application here. So this is the type of application that we're going to be make use of it in our training program. So this doesn't have any ID. The output is always will always go to the console, okay, which is your command window. I'm just saving the default location with a C temp, and I'm just going to keep this as my first .NET program. Okay, this is my first .NET program, and of course I'm going to I'm going to deselect the version control here. Otherwise, I can add this project to the version control directly. But for now, I'm not interested. And create a directory for that. That's fine. So this is, again, you can actually check this box. This box is checked by default. You can keep it so that it's going to create a separate folder for your name under ctemp to create your project, so which is nice. Okay, good. So I'm going to say okay. It's taken a little time to create the use the template and create the project for me, and by default I have this as the program output. Okay, so a couple of things to know. This is the standard program structure that you will see in C#. Of course, not only C#, any .NET programs ideally, but only this the literals or the syntaxes might change, like the using keyword you see in C#. Otherwise, in VB.NET you'll see import statement in place of this. Otherwise, ideally it's same. And the namespaces, again, in VB.NET it starts with the capital N, and here it's a small n, namespace. C# and VB.NET go side by side always. VB.NET is more like an English language, wherein every sentence starts with a capital letter. That's what you'll see. Everything starts with a capital letter there, whereas in C# everything is small case. Like the N in namespace is small, C in class is small, S in static is small, so on. VB.NET, it is just opposite to it. Okay, let's not go too deep into there. Today we're going to see the what's an assembly. Okay, to see what is an assembly, we'll see what is this project properties look like. So the core thing that I'm interested here is the output type. If you see the output type, since I have created a console application, the output type of my project is marked to console application. Okay, and there are two more available here. One is a Windows application and class library. So if I pick this class library, then my output will be a DLL file, and for these two it will be exe file. Okay, and for Windows applications it will make use of the Windows Forms library, and you will have a GUI for that, whereas for console application you won't have a GUI for that. As you see, I just have only a program.cs by default. I don't have a form, FORM. Okay, so what does excuse me, so what does this have? What I'm going to do is I'm just going to say hello world. And since it's a console application, I just have to write my console to the console, and I'll say hello world. Okay, and so that I have my window keep open, so I just want to say read, so that it's going to wait till I say something. And now I just run this program. So that's my first program, so wherein I just say hello world to my console. So as I said, my console program opens in the command line window, which is just black background and white text. Of course, you can change the background and text and other things. That's a different story. So the console application output is going to be pretty much like this. Okay, since my read, I just say enter, it's terminate the program. So that's my program. Now we'll see what are the things that are by default referred in this case. So it actually referred to a couple of assemblies, and these references are as part of the template. Nothing that is added so that this is required by this program. So all of this, if I take it off, can I still compile? No. See, the console is gone. So where is this console coming from? How do you know where is this coming from? There are multiple ways to find from where this is coming from. Okay, so this is coming from system. So because I know that this is coming from system, I am able to put it directly there. If I don't know, how can I find? So that's a comment in C#. How can I do that is just copy this, go to the Object Explorer, Object Browser in other words, and search for the console, and you'll see a ton of things here. Within that, the first one, if you see, this is called system.console. Okay, so this indicates that you're on the right hand side, it gives you that the console is a member of system. So this is the way you can identify which is the namespace that you need in your program. So Object Browser in your IDE is one of the very important tool available to look up into your base class libraries. So this will ideally going to search into the not only the base class library but also the libraries that are referred in your program. It could be your own other program. Okay, so that way you can determine which is the namespace that you need. And one of the best practice is to keep only the namespaces that are required in your program. In the earlier case, if I see I have a couple of other things like the XML or collections.generic and other things which are not required, but keeping them as a reference will actually slow down your performance. So in this case, I can also take these references out. System.data I'm not using. Now I'm going to make these remove all of these manually. So keeping this way, two things you're going to achieve. Your program is going to be very concise, and also while you're loading the program itself, need not load all those DLLs into the memory. Okay, good. So this is my program and now we'll see what is the output that I have. To see an output, what in Visual Studio what you can do is right click on this, and there is something a small tool at the bottom says open folder in Windows Explorer. Okay, so this is the easiest way to navigate to the folder in the Windows Explorer where your code files are sitting. Okay, so once I compile, you will see two important folders here, bin and obj. These two folders are temporary folders that are created by your IDE to manage your execution of the program and debugging the program inside the IDE. So obj is the folder where the program output is going to be created temporarily before it creates the final version that you're going to work with. So ideally at the end of the compilation, you will see the files in obj and bin will be same, except the final output is actually moved to bin folder under a debug folder. Of course, you can have a release mode. If you compile in release mode, then you will see a release folder under bin. In this case, since I have built this with using the debug mode here, which is by default, the folder is created. In other words, I can actually pick the release mode and compile this, and I should see a release folder. So that's the mode that you pick. Based on the mode, the respective folders will be created under bin. So that's the basics again. Again, what will be the difference between the debug and release when you choose? When you make a release item, you can actually, this is the option that you would like to choose or you need to choose when you're actually create a deployable components that need to go out into the respective environment wherever you want to deploy. In this case, you want to choose not to have the debug information like PDB files, and of course if you see the VS host files, these are the files that are created by the Visual Studio, which contains the debug information as well. What it means by debug information is the output of the program will also have the reference to the line of code that each line is going to do. That information will help you to have a debug. Like for example, if I have a debug pointer here, that information actually goes into your debug file, and also the line information. Inside the debug mode, if I run the program, the IDE can actually go and stop there and help your program to freeze at that point and give you a hold to the developer to manipulate the execution at runtime. So for that facility, it takes the debug information along with the compiled one and puts inside the VS host exe file, and also it contains the manifest file. And otherwise, if you see the size of this exe versus this exe, this almost it's more than a 50% rack. It's like 40% of the VS host exe file. Okay, so that's a little bit of fundamentals when you create an object. So the key thing here is the output. So this exe is an assembly. In other words, if I right click this exe and go to its properties, I can see a lot of information about this assembly with respect to the security policies that you can apply to this, and also the file description, the application, and so on. These are default assembly attributes that you can normally see. So this is actually extracted as part of the, if you know the file attributes, similarly these are the assembly attributes, and you can of course set all of them inside your project properties. Okay. If you go to the assembly information, you can actually set your assembly information at this point here. And also, if you take a look at the properties here, there is something called a file called assemblyinfo.cs under the given properties dropdown. So again, this structure is not specific to a console application. If you open any application, or it could be a Windows-based application, it could be a web application, this is a standard. Okay, so none of this will be different. Only the output is going to be different, like it's going to be exe with GUI or without GUI, so on. Otherwise, you'll see the assembly information same. So within this file, you can, of course, optionally add the assembly tag and write down the respective attributes. And there are more attributes available to you when we deal here. So if you look at the assembly attributes here, ASS, so all these are assembly attributes. So there are a lot of information that you can actually attach to the assembly, more than ones that you see in the project properties window. Okay, out of that, most importantly, these are the two things that you really need to pay attention, because this is the version information that is very, very important for any application. So that's what derives or differentiate your code that you're releasing as part of a given assembly version. So this will go as part of your assembly, right? And if you right click and see the properties details, so this is the file version, and of course the product version as well. So you can specify the version for the given project. So that assembly information, normal build scripts that you normally build with using either MS build or an build scripts, or those you can automate to manipulate this information when you do a bulk release or bulk build operations that normally happen for large scale projects. Okay, good. So that's the assembly information. Now, this is another, in other words, we refer to as a metadata. Okay, so this metadata sits along with the assembly. So now we'll see how the MSIL looks like, the intermediate language. Okay, to see how the MSIL looks like, what we need is the .NET reflection. The .NET reflection is the process through which you actually read the information that is inside an MSIL or assembly attributes. To make that possible, Visual Studio comes with a very gifted tool called the ILDASM, which is available in 2010 under the Windows SDK tools as an ILDASM. And in other words, in the earlier versions, the tool is not actually listed inside your the program's menu items. And in that case, oops, I clicked the wrong one. This is not what I wanted. In those cases, if you're not having a 2010, what you can do is go to its respective command prompt. The command prompt is here inside the tools, and that's available even in 2008. Under the tools, you have the command prompt. So if you go to the command prompt, you can actually run the respective programs directly from the command prompt. ILDASM is the exe that I'm interested. So this way I can invoke this tool. This stands for Intermediate Language Disassembler. Okay, this will help you to read through the respective. So I just copied the path where my first output is here, and I'm opening the exe. So in my, this is the manifest that we are referring to, and this is the rest of the code that goes in. So what do I have in the manifest? So this is the same information that I see under my assembly information.cs, assembly info.cs that I'm trying to set to. Okay, so that's the information. It comes with the public key token, and also since right now it's just a console application, it doesn't have any references to other DLLs and other projects. It's relatively simple and plain. And as you see, this is completely human readable except the values that are assigned to it. So these are binary chunk of information that are compiled to it, but of course you can still see the human readable text on the right hand side, right? And so this is what the manifest is all about. And again, this will have the if I set up a couple of security policies, all that information will come in as part of the manifest. And coming down, so we'll see the code. I can also see the code. CTOR stands for the constructor .ctor. So I don't have any constructor written here, but .NET by default creates a default constructor for my program. So what is a constructor again? So if you're not familiar with what is a constructor, then don't worry about that. We will see constructor in detail in the forthcoming sessions. And the only function that I have in my code here is the static void main. And why this is static, why it is void, what is this main, we will see all of that in the forthcoming sessions. For now, we will see what is an assembly and how it looks like. Okay, and inside this assembly, this is an intermediate language. So this is how the IL looks like. So this IL, if you see the IL and underscore the line, the respective line of the code, and this is the IL specific instructions that you see. And LDSTR is hello world, that means list the string on your display. And void, it's going to if you see the mscorlib, I haven't referred this mscorlib in the project. If you see, we just have a reference to system. Using systems is the only one reference we have, but mscorlib is not referred. As I said, this is referred implicitly, and you cannot control that, because without the mscorlib reference, you cannot actually write even anything, including the using keyword itself. You cannot make use of it. And what is inside the mscorlib, can we see? Yes, we can see. Using the same ILDASM, because mscorlib is again a .NET assembly, we can easily open it and see. Okay, good. So we'll see that immediately after walking through the IL language here. This is the IL for my main method, and if you see, this is the plain English readable, human readable text, which is system.console.writeLine, which is the line of code that I have here, which is console.writeLine in this case here. Okay. So since I passed the hello world as a parameter to this, it took this parameter outside it, and it's just making the call to the respective WriteLine method of the console.writeLine class. This is the class name, and this is the namespace, and this is the method name that you're going to call, and pass the value that is stored in this line into this part. So that's how the instructions go. We don't want to really learn how the IL look, how to write IL, but just want to know what it contains. So that's the IL, intermediate language. Okay. So in mscorlib, can we see the mscorlib? Yes, definitely we can see mscorlib. How do we go there? We just have to go through C, Windows, Microsoft, .NET, and framework 2.0, and this here we should see mscorlib. Yep, this is the library that we want to see. I can simply open this, and it does have the manifest, and if you see all the DLLs that is referring to, so this is a mscorlib that is referring to the other DLLs, and especially if you remember the extern keyword, that's the key thing that again important here. The extern keyword in C# or in .NET refers to the DLLs external to the .NET. So these are the DLLs which are unmanaged code, in other words. So these are the DLLs specific to the operating system. Example, if you know the kernel 32 DLL, it's here, and user 32 DLL relates to the security things, and secure D32 DLL. These are all DLLs specific to the operating system. So mscorlib is the endpoint in the .NET. So it does have a lot of other references. We don't want to really know what each of these do, and of course what it does have is the, if you take a look at in the ILDASM, so the icons are self-explanatory. So if you look at this icon, this stands for like a shield, this stands for the namespaces, and the other, these are looks like a components. So these are component references that you can see. We'll expand the system namespace. System is the root namespace, FYI. That's a very common, very important question in .NET. What is the root namespace? The root namespace is system. Keep in mind, that's a very fundamental question. So as you see, the system is the root namespace. Once I expand this, I'll see all the other assemblies inside this. So it's ton of other things, like I don't want to name each and every of them. A simple one of the common thing is system.math, system.object. If you see, again, system.object itself, if you see, this is a component like icon. This indicates that this is a class. Okay, and if I expand this, I can see what a system.object contains internally, and also I can also see the code, what it is internally written to. Okay, there is one more interesting tool. This is very intuitive, ILDASM, but there is a much more powerful tool to do all of this in a very user-friendly way. That's from Redgate software. The name of the tool is the .NET Reflector, and if you can get that tool, you can actually do that in a more user-friendly way. Okay, good. So that's, again, right now it used to be free, but now it costs $35, but still you can have a trial version down. And that's all about the assembly and the manifest information that we can look at. And multiple versions can be deployed side by side in different folders. Of course, that's again one of the most valuable addition in .NET is you can have multiple versions of the same DLL sit side by side inside the GAC. And again, what is that GAC and how you do that, all that again we'll see in the following session. And there are two types of assemblies. One is a private, another one is a public shared assemblies. The private assemblies are the assemblies that you can actually refer them into your projects, and they are specific to your specific project. And when you're referring a given assembly, they don't have to be sitting anywhere, just like COM. If you know what is a COM, like component object model, which is fine. For those who don't know what is a COM, that's one of the very, very popular technology that Microsoft has brought into the industry a decade back or 2 decades back probably, and industry has heavily used the COM in their implementations. That's one of the only way, in other words, available to develop a distributable applications or distributable components in that given time period. So component object model, there are a couple of drawbacks now, and one of the drawback is that the version compatibility issues. Once you have a version release, releasing another version is another pain, and also using the respective components into a given application is strictly done via the Windows registry. That means you need to actually register the respective components, and only when the components can be referred into another program and can be made use of it. Although the code wise it's a distributable component, but there are a couple of hurdles in the day-to-day maintenance wise as well as consumption wise, and reusability of the components is one of the key drawbacks the COM suffered with a lot of criticism. And .NET actually, because it's completely again Microsoft standard, so which can be of course written in any language. So it has a couple of interfaces. We will cover COM in detail in the forthcoming session. Today I don't want to get into much of it. So the point here is when we compare the COM with respect to assemblies, the couple of differences. For private assemblies, you don't have to register that anywhere. It's just a DLL that's available out of box. You can just put it in a given folder within your project and just add a reference to it. Again, how to add a reference, I will show that down the line, don't worry. Add a reference to your project just the way we have added a reference, or we see the reference being added to system.dll. Same way we can add a reference to a third-party DLL and consume it. You don't have to do anything else. And for shared assemblies, definitely, because multiple users are going to share the same assembly, so there should be a common repository, just like a Windows registry, so that the different multiple applications can refer to the same assembly and make use of it. A simple example of that could be your printer utilities that are sitting in your machine, or it could be a Crystal reports engine that's going to run, and also it could be our data access components or ODBC components for .NET that you want to make use in common for multiple applications on a given server. So in that course of scenarios, those DLLs or those assemblies need to sit in a common repository, and that repository is called a GAC, which stands for Global Assembly Cache. So for those to sit inside a Global Assembly Cache, those are called the public assemblies. Okay, and a private assembly, again, that's what this text is talking about. And for private assemblies, they are again deployed and use it directly. That's what it's talking about. When the component is removed, no registry cleanup is needed, unlike the COM components, and uninstallation and nothing is required. For private assemblies, you just have to delete that, it's gone. And in case of a shared assemblies, it need to get into the GAC. So that's all this slide is talking about. And of course, namespace versus assembly, and we haven't seen what is a namespace so far, right? What is a namespace? Okay, the namespace in simple. If you want to visualize a namespace as just like your folder structure. I just quickly open the folder. The only best reference I can give you is visualize a namespace just like a folders inside your Windows Explorer. But the folders that you see, these are physical separation of files, right? So which under each folder I have different set of files sitting, right? So this is a physical separation of these files. Whereas when you talk about namespace, it's the logical separation of classes. Okay, so .NET is completely built with classes. So the namespace is just a logical separation. In this case, my first .NET program. So that's the namespace. So this is, in other words, logical, because that's not a physical separation, because I'm having that inside a physical file called program.cs. If I go to my folder, that code is actually sitting inside this physical file as program.cs. Okay, I said logical because I can have another namespace like this. I just copy this, or I can even type this namespace, my namespace. I can have my class inside this. So within the same physical file, I actually have two different namespaces. So that's why a namespace is just a logical grouping of related classes. So that's the line you can answer to anyone. And if you understand what the logical definition means, that's what this is. So it's not a physical separation, but although this is a logical separation, but you can still visualize this namespace is just like a folder structure. So you can visualize this as a folder, and under which you have these classes. Okay, so that's how you use namespace to group a related classes. And when you're referring them, you refer using the namespace. And the best example is here, system. The system is a namespace that's available in this DLL, which is system.dll, right? And similarly, I have other namespaces. Since I haven't added reference to many others, I have system.io. So this is another namespace which comes as part of your system, as well as mscorlib. Okay, so this is a namespace. Namespace is a logical separation. So now what is the difference between a namespace and an assembly? So assembly, as you see, has a single deployable component, which can be a DLL or an exe, and namespace can span multiple assemblies. So as I have a multiple namespace can be sitting, multiple namespace can I have it in the same file, and also I can have the same namespace in a different assembly also. So it doesn't matter. So the namespace can span across assembly. Whereas since namespace is a logical separation only. Namespace is a logical grouping of classes, and whereas assembly is a physical grouping of logical units. So that's the core difference between a namespace and an assembly. Okay. Again, ILDASM, we just saw what is an ILDASM, so this is good. And I don't want to again walk through this slide, which just stands for intermediate language disassembler. And of course there is another assembler. When you say disassembler, there is an assembler called ILASM, which is used by the compiler to build the assembly, to bring all your information that you put in as assembly and build this. We'll see more of that in the forthcoming session followed by. Okay, manifest, we did see what is a manifest. It contains the metadata, metadata of the given assembly, which contains the information, security, identity, scope of the assembly, resolve references to resources and classes. The assembly manifest can be stored in either a PE file. As I said, PE file is portable executable file, which is a Microsoft standard for standalone PE files. And that is, in other words, is an exe or a DLL. In other words, the PE is a portable executable. But DLL is not executable, but it's need to be consumed by another exe. Okay. Code access security. Code access security will allow the restrict what code can do, and restrict which code can call your code, and identify code. Just for a typical example is file access or memory access. If you were writing a code that needs to have special permissions to access a given memory area, then you need to be your policy need to support, and as well as your compiler need to be aware of. So such things you can convey to the compiler by using respective keywords like an unsafe keyword to write an unsafe code, and also to write the file IO operations. You need to have a specific permissions need to be granted as part of the policy that you want to set up. And that's all about the code access security. We will see a little more of the code access security in the forthcoming sessions. And language interoperability, and this is one of the core functionality or the richness of .NET framework. What are the components that are responsible to deliver the interoperability? Again, what is interoperability? Okay, the question comes here. The answer for what is an interoperability is, if you see our previous slide wherein we have the languages as a topmost in the ladder, wherein C#, VB.NET, or F# and so on. So what happens is, if I write a program in C# and I want to use or consume that in a VB.NET program, I can still do that. So that's called the language interoperability in .NET. So write the code in one language, but you can use it in any other language. So how it is possible? It is possible by using two set of concepts. Number one is a CTS and the other one is CLS. CTS stands for Common Type System and CLS stands for Common Language Specifications. So we'll see what is CTS. In order that two language communicate smoothly, like CLR has CTS, Common Type System. For example, what are the challenges you'll see when you're referring to two different languages? Number one, I'll quickly jump into a program instead of running through the slide. In this case, I'm going to write of course, extend the same program. Okay, adding a variable here. Okay, I'll say instead of a string, I'll say int. I'll say I. Okay, I can even use comma, but I would just wanted to keep it separate. I is equal to 10 and I is equal to say 5, and I'm going to write this out using a string. Oops, string.format. Okay, the sum is the sum of I'm just adding a placeholders here is okay, so this is 2, which is I comma j comma I plus j. Okay, so this is what I want to just print out. Okay, there is a semicolon close brackets. The program compiled successfully. I'm going to run this program to make sure it works. Yes, so I see I just wrote a program in C# using data types called int, and result is sum of it using a simple write line. Okay, so same program I want to write using a VB.NET. Add a simple VB.NET project, new project. I'm going to choose other languages and say Visual Basic. Again, I'll pick the same console application, and I'll say VB project. Okay, so just some name. Okay, so in this case, of course, let's not worry too much about the structure, the way it looks like, but all I care is to write the same set of program in the here itself. So how do I do that? In VB.NET, it's a dim I is equal to 10. Dim, oops, there's no semicolon in VB.NET, so okay, j is equal to 5. but of course I can still have my console.writeLine. Console.writeLine, I will say, of course I did this string dot formats in the other case. Here I can actually do without that. Well, let me try. Sum of I, okay, that is 0, the placeholder, and 1 is 2, and of course I can pass I comma j comma I plus j. Okay, so that's all I need. And console console.read. So if you see the console.writeLine, oops, now console.writeLine and readline both are same in the both languages. Okay, except that the way the variables get declared, I'll just make this as a startup project here. Right click and say start a project, and then run this program. Okay, so this is a VB.M project to make sure. So this is a VB project, and the output is 10 plus 5 is 15. Okay, which is good. So my point of interest here is the way the same line of code is written in both the languages. Okay, so if you see, these are the two statements which are identical in both the languages, except the way the variables are declared. In the VB.NET we have a dim I is equal to 10 and j is equal to 5, and here it's just data type and the variable name and the value. Not only that, so when you talk about the more different languages, it could be like int in VB.NET is a 4 bytes of data, which is a numeric data. And it is of course not assigned data. You can have unsigned values as well. In a different language, the whole definition of the int can be different. It could be limited to 2 bytes of data. Its size itself is 2 bytes, and it can be assigned integer and so on. So it can be. So this is a wide definition, wide problem that you have when we talk about language interoperability. So writing a code in VB.NET and making use in a C# is one thing. So to facilitate this, how did what is a common type system that we have? So if I open this output again, I want to have the copy of the respective exes. If I open this code in ILDASM and I see what is the data type it's actually used. Okay, oops, I don't have the latest one here. Let me, oops, because I have all set this to release mode, that's why it's not going there. I quickly change that to debug mode and again do a rebuild solution. Good. Now I should be able to see the changes. Good, I think so. And I'm going to run this again and open the code in ILDASM to see what is the data type that it is actually using. Okay, there you go. I can able to see the changes that I did. Okay, what is the data type that it is assigned? It's actually assigned the system.int32 from mscorlib. Okay, this is the data type that it is using, system.int32 for both all of my data types. Okay, this is for my 10 and 5 and everything. So that's from my C# program. Okay, I'll keep this aside. And now I'll open the VB.NET code as well, right? Where is VB project, bin, debug, and VB project.exe. And that's the same thing here. Oops, I want to do a side-by-side comparison. Do I have the old window open? Looks like looks like the other window got replaced with this one. So the point here is the type system. So both the languages have the same representation in the intermediate language. So it identified int in C# and integer in VB.NET. Both are represented as system.32. So this is a common type system that makes possible for languages with the different data types talk to each other in the .NET frameworks. So that's the CTS. So the rest of the text is going to talk about that same thing only, so which we saw in demo just now. Okay, so we can skip this part. So this is the same thing that we have seen just now. Integer in VB.NET and int in C#, both refer to int32. Okay, so that's the representation in the intermediate language. Similarly, in your instructions like the if statements, else statements, switch cases, the language specific operations are also represented as using a CLS. So this is all about the intermediate language, in other words. So CTS and CLS are the specifications that one need to know to write a compiler. The CSC is the C# compiler that compiles the C# code to a executable, and it need to be self-aware of the specification on the CLS and the CTS. And just like CTS, CLS also have the rest specifications for the language. In this case, in the C#.NET, the if and else statement, if you see, the instruction set in MSIL is same for the same line of code in different languages. So that's the CLS stands for. So CLS talks about the intermediate language, in other words. That's a common language specification. So we did see what is a namespace again. The slides talking about the namespace and the GAG. So we will see continue with the GAG in the following session. I'm going to take a break at this point and see if you have any questions in this first session, and also would like to see any feedback from your end if you want to hear more, or the approach that you want to see in the going forward sessions, and I truly appreciate your feedback from the first session. So we'll see more and more in the forthcoming sessions in much more deep dive into a couple of core elements of .NET. Okay, and let me see if you have any questions at this point.